Hello everyone, welcome back to 𝗏𝗏𝗃𝗃 YouTube channel. In today's video, we are going to discuss the solutions for latest CodeChef contest Starters 171 Division 4. So let us start with the first problem, Squid Game Piggy Bank. Yeah, in the deadly Squid Game, the participant starts with n players. So there are n players. After the game ends, only k players survive. So I hope you know how Squid Game works. There will be n players and k players are going to survive. The prize pool increases based on the number of players eliminated. Each eliminated player contributes a fixed amount of 10,000 units to the prize pool. Your task is to calculate the total prize money added to the pool given the number of players n at the start of the game and the number of players who survive k. Yeah, so there are n players, and during the game some people will be eliminated, and at the last k players are remaining. And whenever a player is eliminated, the eliminated player contributes a fixed amount of 10,000 units to the pool price. So this is the catch here. Let us understand the input format. The input format contains two integers n and k. N is the total number of players at the start of the game. K is the number of players still alive after the game. So these are the players who are going to survive at the end of the game. Now the output, we need to print a single integer, the total prize money added to the pool. Let us understand the sample test case. So there are 10 players and 5 people are remaining at the end. Now you need to calculate the total prize money added to the pool. So how is the total prize money decided? It is decided on the people who are eliminated, and each eliminated player is going to contribute 10,000 units to the pool price. So if you observe, initially there are 10 and at the end there are 5. Means how many people are eliminated? Obviously 10 minus 5. So 10 minus 5, which is also 5. So 5 into 10,000, which is 50,000. So this is our output. So the question is straightforward. Now if you observe the second example, 89 and 33. So initially there are 89 and finally there are 33. The eliminated players are 89 minus 33, which is 56. So 56 players are going to contribute 56 into 10,000, this much amount to the pool price. So converting this logic into code. So according to the input format, we will take the number of people who are in the beginning and then the number of people who are left. So we have taken the two values. Then how will you find the pool price? Pool price is nothing but the number of people who are eliminated, which is n minus k. So let's take our answer, which is equal to the remaining people who are eliminated, n minus k into 10,000. So finally you will print the answer. Okay. We got the expected sample output. Let us submit this. That's it. So very simple problem. Let's move forward. So let us move forward with the second problem, 𝗟𝗲𝗃𝗃𝗹𝗶. Tufan wanted to write the string 𝗟𝗲𝗃 but accidentally wrote the 8-letter string S instead. He wanted to correct his mistake with a minimum number of steps. In one step, Tufan can choose an index I. So this is one-based indexing, and change SI to the next letter in the alphabet. So that is change A to B, B to C, C to D. So these are the next letters, right? And so on. The alphabet is considered cyclic, so Z can be changed to A. So cyclic in the sense alphabets are moving like a cycle. So A to B, B to C, so on. Then after Z you will reach to A. So this is a cycle. So we can move like this. For example, if s is equal to this string, let's see how we can perform the steps operating on the first index. So let us take this string. So this is our string Z A R A G O Z and A. So this is our string. Considering one based indexing, 1, 2, 3, 4, 5, 6, 7, and 8. Now we need to convert this string to 𝗙𝗵𝗊𝗨𝗨, this string. So 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, we need to convert this string to this string using the steps. So let us see what steps we are going to use. So let us understand the steps. So for example, s is equals to this. So this is our string. Now operating on the first index will turn s into this. So operating on the first index in sense this z. So this z is converted to a in one step. So one step in the sense, as I said, the next character after z is a. So z will be converted to a. So this is the string. Next, operating on the second index will turn s into. So this is our string. Operating on the second index, a. We will convert a to the next character, which is b. So this is our string. Similarly, operating on the third index. So third index, this character. So we after r, the character is s. So this string, next, and so on. So we need to convert such particular strings to this string. So this is our main motto. We need to find the minimum number of steps required to convert the string s to 𝗙𝗵𝗃𝗃𝗃. So the problem statement is very direct. Let us understand the input format. The input contains integer t, the number of test cases, then t lines, each contain s consisting of exactly 8 uppercase letters. So the input string is exactly of 8 letters and all are uppercase. And output format, for every test case we need to output a single integer on a new line, the minimum number of steps required to convert s to 𝗙𝗵𝗃𝗃. Coming to the constraints, so t is less than or equal to 1000 and greater than or equal to 1. S is exactly of length 8 and each character of S is uppercase English letter. So let us understand the problem statement better by taking sample input. So 𝗙𝗵𝗃𝗃, the given string is 𝗙𝗵𝗊𝗨𝗨 and our original string is this. Now in how many operations can you convert the given string to this string? So if you observe, both are same, 𝗙𝗵𝗃𝗃. So the minimum number of operations are 0. You need not change any character. So the output is 0. Let us understand the second example. So the given string is this. So we need to convert this string to our original string in minimum number of operations. So let's see. So do we need to convert this a? Not required, because this is already same. So you need not do anything here. What about the nothing? V, nothing, nothing here, nothing here, nothing here. But coming to this character, so here we are supposed to convert our a to y. This a is same. So according to the example, at the 7th character, you need to convert a to y in minimum number of operations. So how do you convert? Further, we have seen in one step you are going from A to B, then in the next step B to C, C to D, D to E, and so on till Y. So this is going to take 24 steps. That's what is mentioned in the output. So if you go on like this from E to F, F to G, so on till Y, it will take 24 steps. That's it. This is all about the output for the second problem or second example. Let us try to solve this. So let us understand how we are going to solve this problem. So to solve this problem, we need to take two cases. So before taking two cases, let us take the current character and the target character. So current character is the character of the given string. So let's take it as A and the target character as Y. So in our first case, the target character is going to come after the current character. So obviously A comes after Y. So to convert this, we can simply count the number of characters between A and Y, including Y. Yes, so how will you find that? Let's take the ASCII value of A, which is 65, ASCII value of Y, which is 89. So the number of characters are nothing but 89 minus 65, which is equal to 24. This is how you got the output as 24. Now moving to the next case, where the current character is Y and the target character is C. So in this case, what I meant to say is the target character is going to be before the current character. So if you observe alphabetically, C comes before Y, right? So that's what I meant. Now the number of steps required to convert Y to C are, what are the number of steps? So to convert Y to C, you should first cross Z. So first you will cross Z, from Z to A to B, then B to C. So this is the number of steps, 1, 2, 3 and 4. In 4 steps you can convert Y to C. So how will you solve this? So if you observe, we are going first from Y to Z. In how many steps? Same, you can take the ASCII value of Y, which is 89, and then Z, which is 90. So in how many steps are we going? 90 minus 89, which is equal to 1 step. In 1 step you can reach till Z, including Z. Now the number of steps required to move from A to C. So if you observe, or we can also consider from Z to C. Z to C, how many characters? You need to cross A, B and then C. For this you can simply take the ASCII value of C. What is the ASCII value of C? It is 67. ASCII value of A, it is 65. So count the number of characters between A to C, including A, B and C, because you are jumping on these characters as well, which is equal to 67 minus 65 plus 1 equals 3. So in general what we are finding is, in the first case it is simply the ASCII of target minus ASCII of, but in the second case we are first jumping to Z. So for that you will take ASCII of Z, your current first, then ASCII of your target minus ASCII of A plus 1. So we are finding like this. So this is to reach till Z, then this is to reach from A to that particular character. Got it? We'll take these two cases. Let us convert this logic into code. Let us convert a logic into code. According to the input format, let us read the number of test cases. Number of test cases. Then we'll iterate on the number of test cases. For every test case, you are supposed to read the string. And we are comparing the given string with the original string. Our original string is fixed, which is 𝗙𝗵𝗆. This is our original string. Then we will find the number of steps by taking an answer which lies to 0, we'll iterate on the given string using zero-based indexing. So for that, let us start our I equal to 0, then I less than. So according to the length of the string is fixed, which is 8, as mentioned in the problem statement. It is going to contain exactly 8 uppercase letters, and both the strings are of size 8. So we will iterate, and we'll directly take the ASCII values of the particular characters in the given strings. So ch, okay, let's take current. Current is the ASCII value of that particular character in the given string. So int of is dot char at I. Then let's take the ASCII value of the target, which is equal to int of original dot char at I. So you got these two values. Now we'll take the two cases. If your current is less than or equal to target, means either your current and target character are same, or the target is next to the current character. So in this case, we can simply take the number of characters between target and current. So target minus current. Else, we will first iterate on the number of characters from the current to Z, then Z to A, and A to that particular character. So for that, let us take the number of characters between the current character and Z. For that, you will take the ASCII value of Z minus the ASCII value of the current character plus the number of characters from A to that particular character including A. So for that, you can simply take the target minus ASCII value of A, which is 65 plus 1. And finally, you will print the answer. Let us run it. Okay, we just missed a semicolon. So we got the expected output. Then we will submit it. That's it. Let us start our discussion with the problem switch game. Tufan is playing an exciting game where there are n rings, and for each ring, Tufan can either swish or pass. The goal of the game is to achieve at least k swishes. The game will end immediately when at least one of the following two conditions is met. Tufan has finished all the n rings, or it is impossible to win the game anymore. This means it is impossible for Tufan to get at least k swishes regardless of what he does with the remaining rings. Tufan knows the value of k, the number of swishes he must achieve, and remembers the sequence of moves he made. However, he no longer remembers the value of n, the number of rings. You are given a string S of length m, denoting the moves Tufan made during the game. Each character of S is either S denoting a swish or P denoting a pass. Given Tufan has entered the game exactly this sequence game after exactly this sequence of m moves, what could be the value of n? So you are given a sequence of m moves, we need to find the value of n. So let us understand this problem by taking an example. So let us understand the problem statement better by taking an example. So you are given the value of m equal to 3, means after 3 moves the game has ended. This is a sequence. Then k, the required number of swishes by Tufan. So let us understand this. It is mentioned that game has ended. When will the game end? The game will end whenever the rings are exhausted and whenever the Tufan feels that he is not going to win the game. But here, Tufan is not going to end the game because he need 4 swishes for himself. But even though he got only 1 swish, he has entered the game. Why? Because to get 4 swishes, how many swishes or how many rings does Tufan need at least 3 more rings so that he can get 3 swishes here. But if he knows that he's going to get 3 more swishes with the 3 rings, he could have not stopped the game. So the best possibility here is he is having only 2 more rings. That's why he has ended the game. So finally, what are the total number of rings existed? 5. So the value here is 5. Now coming to the next case. Here, if you observe, first it is a pass, then it is a swish. But once it is a swish, he did not end the game. Because he has a possibility to end the game whenever k is equal to 1, he could have stopped the game. But the game is not going to stop once the swishes are completed. The game is stopping when the number of rings is exhausted. So to exhaust the rings, so he played one more turn and it is a swish. So here all the rings are completed. So the number of rings is equal to 3. So this is all about the explanation of the example. Let us see how we can convert, how we can come up with the logic. Now we should take 2 cases. Whenever in the turns, let's take 2 turns. These are the sequences played by Tufan. In these sequences, we'll count the number of swishes. So number of swishes. Let's take that as some count of swishes. Now, if the count of swishes, if it is already greater or equal to the required in the sense k. If it is already greater than equal to k, but even though he is playing, means he is trying to exhaust all the rings and end the game. So in this case, the number of rings is equal to the size of the sequence, which is equal to n. So in this case, the value is n. Now one more case. Whenever the value of this count is less than k, and even though he stopped the game, means he felt that he cannot get any switches in the following moves and in the following rings, so he has ended the game. So for that, what are the number of rings he has, when will this such case exist? Whenever the number of rings is not matching the required number of swishes, which is nothing but, so the required number of swishes is, what is the required number of swishes? So it is k minus count. This is the required number of swishes. If chef feels that he is not going to get this many required number of swishes, then he'll end the game. So when will such case exist? Whenever the number of rings is not matching the requirement, which is nothing but number of rings leftover rings is equal to required minus 1. If in this case chef is not going to move forward, he is going to end the game then and there itself. Now for this case, what is the total number of rings? It is n plus left over rings, which is equal to, yeah, that's it. If you want to simplify it better, we are simply writing it like n plus k minus count minus 1. So this is the answer. I hope you got the solution. We need to assume 2 cases, guys. So whenever count is greater or equal to n, greater or equal to k, even though after getting the required number of swishes, if he is continuing, means he is trying to exhaust the rings and end the game. But whenever the count of swishes is less than the requirement and he is ending, means he felt that there is no possibility of getting swishes since the number of rings is not sufficient for getting swishes. So that's why he ended the game. That possibility comes whenever the value of rings is n plus leftover number of rings. That's it. So let us move to the coding part. According to the input, the first line contains the number of test cases. We'll return the number of test cases, and for each test case, you are having two space separated integers m and k. Then you have the string. Now we will find the number of swishes in the string. So for that, let us iterate on the string. If your string is equal to s, means it is a swish. So we will count it. Now we'll check if the count is greater or equal to k, greater or equal to the number of swishes he needs to achieve the win. If it is even greater or equal to k and he is moving forward, means those many number of rings are present which are needed to be exhausted. So it's nothing but m. He is trying to exhaust the rings. How many rings? M rings. Else there are no sufficient rings. So how many rings are required? So for that, we need to first take the requirement, which is equal to k minus the actual swishes, and the leftover ring should be less than this. Only if they are less than this, it is not possible to get the number of swishes, and he will end the game. So for that, the number of rings leftover will be this. So the total number of rings will be equal to m plus the leftover number of rings. Let us run it. So we received the expected output. Let us submit it. So let us move to the fourth problem, white wall. Tufan loves white walls. He recently printed a wall with some colors red, green and blue. However, he realized that the wall doesn't look as bright as and white as he imagined. Tufan's wall has length n, meaning it has n positions placed on a line, and in each position can be painted in one color, either red, blue or green. You are given a string s of length n denoting the initial coloring of the wall. So you are having a string of size n, and each character in the string is red, green or blue, denoting the initial color of the wall. So let's take an example. So this can be your string. It can have red, blue, green, anything. It is going to be of RGB characters. Anything. Okay. A white wall is defined as a wall where every consecutive set of positions with length divisible by 3 contains equal number of R, G and B. So this is considered as a white wall if every consecutive positions, in the sense consecutive, next positions, this length should be divisible by 3, and the entire string which is divisible by 3 should have equal number of R, G and B. So this is about this statement. Formally, for every pair of integers L and R such that less than or equal to L, less than or equal to R, less than or equal to N, R minus L plus 1 is divisible by 3. There must be equal amount of R, G and B in the substring S, L, L plus 1 so on till SR. So if you take this as your string and some L and R, so L is one index and R is one index. So let us find the size of this particular string, which is equal to R minus L plus 1. This is the size of the string, substring. This length should be divisible by 3, and the substring between these indices L and R should contain equal number of R's, G's and B's. So in our substring It is not containing equal number of r's, g's and b's, but let's take this. So if you take this, so the number of characters here are 2 r's, 2 b's and 2 g's. So this is considered as a white wall. So this is about this statement. Since it is a substring, the remaining part can have anything. This substring is considered as a white wall. Now, for instance, S is equal to 𝗟𝗲𝗃𝗲𝗃. So let's take S is equal to R, G, B and R. This is the original string. It is an example of a white wall. The only substrings with length divisible by 3 are. So what are the substrings which are divisible by 3? So this is a substring whose length is 3. This is a substring whose length is 3. So only two substrings. So there are only two substrings whose length are 3. Now if you observe, in all the substrings, the number of R is 1, G is 1, B is 1, equal. Here also number of R's is 1, B is 1 and G is 1. So that's why this is considered as a white wall. So more formally, if you want to speak, we will take 1 based indexing 1, 2, 3 and 4. 1 to 3 and 2 to 4. That's what this is meant. So the string is RGB and GBR with both equal number of each color. Now let's take one more string. S is equal to R, G, B, R, G and G. Again we'll take 1 based indexing 1, 2, 3, 4, 5 and 6. Now here you are having how many substrings whose length is divisible by 3? This is a substring, this is a substring, this is a substring whose length is divisible by 3, right? It is not a white wall. Why? Because if you observe this substring, the number of R's and G's and B's is equal. But if you consider this substring, it is not equal. We are having 2 G's but no B and only 1 R. And the entire substring, there are 2 R's, 3 G's and only 1 B, which is not correct. So this is not a white wall. Got it? And this is 6 and it is divided by 3. That's what I meant. Tufan can repaint a single position on the wall to any other color in one operation. So he can repaint it. This is the original color, but you can repaint it to any color R, G or B in one operation. Now our task is to determine the minimum number of operations required to transform the given wall into a white wall. So this is a problem statement. Let us move forward. So let us understand the input format. The first line contains single integer t, the number of test cases. Each test case consists of 2 lines of input. The first line contains an integer n, the length of the wall. The second line contains a string s of length n, where each character is either R, G or B, denoting the initial coloring of the wall. Now, for each test case, we need to print a single integer, the number of operations needed to make the wall white. Okay. Then coming to test cases, t less than or equal to 10 power 5, then n less than or equal to 3 into 10 power 5 greater than or equal to 3, then s of I belongs to R, G or B. For all, this is 1 based indexing, I less than or equal to n and greater than or equal to 1. It is guaranteed that the sum of all n across all the test cases doesn't exceed 3 into 10 power 5. Okay. Coming to the input format. The input format, first line contains a single integer t, the number of test cases. Each test case consists of 2 lines of input. The first line contains an integer n, the length of the wall. The second line contains a single string s of length n, where each character is either R, G or B, denoting the initial coloring of the wall. Now the output format, for each test case, print a single integer, the minimum number of operations needed to make the wall white. And coming to the constraints, these are the constraints. Let us focus on the sample input. So in the sample input you are given S, the given string, initial coloring of the wall, which is R, G, B, R, G and G. Now in the given string, what all substrings are there which are divisible by 3? So entire string which is of size 6 is a substring which is divisible by 3. Then you have 3 length substrings. This is a substring, this is a substring, this is a substring, this is a substring. Still anything left? Okay, we'll start from here. 1, 2, then 3 and 4. So there are 4 substrings whose size is 3 and which is divisible by 3. Now all the substrings should hold the condition like number of R's, G's and B's are equal. But do you have like that? If you observe, the substring of size 6 is not having. It is having only 2 R's, 1 B and 3 G's. The count of B and G is not matching with R. So it is not a white wall. Now we need to convert this to a white wall. Let's see how we can convert. So converting white wall means we are converting one color to other color, from R to G, G to B, B to R, anything. So since we are matching the count of B and G, let us make G to B. Okay, if you make like that, let's take this G, this G. Can I make this G to B? No. Why? Because you have a substring. This is your substring, which is not having equal number of R's and G's and B's. So don't do anything to this G. Next, you have one more G here. Can you do something with that? If you make this G as B, what happens? This substring is not having equal number of R, G's and B's. So you cannot do anything with this G as well. Now finally, you have this G. Can you do something with this G? Yes. Let us convert this G to B. Now if you do this, check. This substring is having equal number of R, G's and B's. This substring, yes. This substring, R, G and B. So in one operation, we can make our wall white by matching the conditions of length divisible by 3 and equal number of R's, G's and B's. That's it. So that's why the output is 1. Let's take the second example. S is equal to R, R and R. Now here, what we can do? We can simply convert R to G and this R to B. This is in 2 operations. That's why it is 2. Got it? So this is the explanation of the output. So let us move to the solution. So to understand the solution of this problem, you need to understand a pattern. Let us take the value of your string n is equal to 6. Let's take a string of size 6. Now for a string of size 6 to become white wall, it should follow a pattern. So the pattern can be R, G, B and R, G and B. So if you observe, this pattern should be repeated in the given string. Only such strings are going to contribute white walls. So if you observe here, this is our string, right? So how many substrings of size which are divisible by 3? This is a substring, this is a substring, this is a substring, this is a substring. So here if you observe, number of R's, G's and B's in here are same, here are same, here are same, B, R, G, then RGB, everything is same. So this is a substring which is valid. Now there can be one more substring which is G, R, B, and this pattern also should be repeated. So if you have a string like this G, R and B, only if the pattern is repeated then it can satisfy all the conditions. So if you observe here, one substring, second one BGR, GRB. So all these substrings are going to have equal number of R's, G's and B's. and the entire substring is also having equal number of R's, D's and B's. So this is the core of the logic. This is the important thing. Now such patterns can be formed. We can get lot of patterns using size 6. You can either repeat RGB, or you can either repeat RBG, you can repeat GBR or GRB, or you can also repeat BRG, BG and R. So you can repeat any of these patterns to form white walls. Now whichever pattern is going to give you the minimum number of operations to be converted, then that is your answer. That's it. So let us relate this to our current problem. So our current problem is having RGB and RGG, right? RGB and RGG. So RGB, RGG can be converted to RGB, RGB. So which is our string which is going to contribute white wall. Now this can also be converted to GRB, GRB. We can also convert like this, right? But among this, which is going to give you a number of operations? So here we are only converting G to R in one operation, but here R to G, then G to R, B to B same, then R to G, then G to R, G to B. So it is going to contain lot of operations, 5 operations. So among this, which is minimum? This is going to give you the minimum. So that's why we have taken this and we found the minimum number of operations. So this is all about the logic. So we will convert such strings by repeating these patterns. So this is all about the problem. Now we have seen for n equal to 6. What if the size is 8? So for 8 size string, as I said, the pattern should be repeated. We can take R and G again. Now if you check this particular string, we have added some more substrings here, which is GBR and BRG. Now if you observe, BGR, same, BRG, same number of strings. So in this way we can match our current string with the generated strings. We need to generate strings like this using any of these patterns. Whichever pattern is going to give you minimum number of operations, then you choose that pattern. That's it. Let us convert this logic into code. Let us start with the input. We will read the number of test cases. Then for every test cases, you are going to have the size of the string. Then you will read the string. Now in this string, we are going to compare this string with all our existing patterns. So for that, let us have a list containing the patterns. So the patterns are RGB, then RBG, GRB, GBR, BRG, and BG and R. So these are the patterns. Using these patterns, we are going to generate strings, and with respect to that generated string, we will take the minimum. So for that, let us create strings using these patterns. So what is the size of the pattern? It is of size 6. So now we'll create the patterns. We'll create the strings using the patterns. So the string is, for that you can convert you need to know how much size of the pattern you need to create. For that, let us take K the string ls of I into K. So this is going to create a string which is of size multiple of 3 or a size divisible by 3. Then the remaining string, it is dependent on the remaining characters. The remaining characters are nothing but like the remainder of R. So this is going to fill the remaining characters. So as I said, we have taken RGB, right? Now if the size is 8, the remainder is 2. So we'll take first two characters of R and G. So that is what this is going to indicate. So you got the string. Now with respect to this particular string, you will find the minimum operations. So for that, let us initialize your answer with some maximum value. Since you are finding the minimum value, let us initialize with maximum value. This is some maximum value. Now find the number of operations. So for that, you iterate on the given string, which is of size how much? N. Now your given string is of size n and the generated string is also of size n. Now compare. If your s of j is not equal to the generated string of j, take the count. So let us take the number of operations. Sorry. Now among all the patterns, whichever is giving you the minimum count, take that as your answer. Only print your answer. Right. We need to take ls of for got 1 and 2. Let us submit it. That's it. So we have taken a list containing all our patterns, and then using these patterns we have created a string which is going to contribute a white wall, and then with respect to that white wall string we are converting it into that using these 9 number of operations, and whichever pattern is going to give you the minimum number of operations, that is your answer. That's it. Yeah, that's it for the day, guys. Thanks for sticking till the end. I hope you found the video solutions helpful. If you found them helpful, please like the video and share it with your fellow coders. And if you want to receive more such content, do subscribe our YouTube channel, and also let us know in the comment sections what all videos you want us to create. And see you in the next video.